We're going to have a look at how we can write a fraction as a decimal by using long division. So let's have a look at the fraction 2/7. Obviously, if you have got a calculator, you could work this out very easily, either using a fraction key or by division. So 2/7 means 2 is being divided by 7. So we would write this out just like we would write a normal long division. And make sure you write it down the right way up. So we are dividing 7 into 2. So that looks quite unusual because the number inside is smaller than the number outside, but that's what we've got here, isn't it? We've got something that's a fraction. So we are going to start off by saying, does 7 go into 2? Then the answer is no. So that's a 0 up there. And then 2 is really 2.0 or 2.00000 and so on. So we're dividing 7 into, let's just remember the decimal point there, mustn't we? Okay, we're dividing 7 into 20. So 7 goes into 14 twice, so that gives us a 2 up there, and then we put the 14 down here, and we subtract 14 from 20, and that will give us 6, and then we bring the next 0 in here, and that will be brought down to here. So now we're dividing 7 into 60, so just like ordinary long division, and 7 goes into 56 8 times. And so then we write down 7 8ths, there we get 56. Do the subtraction, 60 minus 56 is 4. And we want our next 0 there, and then that gives us 40. 7 goes into 35, doesn't it? Might as well write 35 there, 5 times. So 5 7 is 35. Do the subtraction, we've got 5. Bring the next 0 down, and that gives us 50. 7's into 49 goes 7 times. And let's just write the other 0, next 0 in there. So do the subtraction. So we've got 50 minus 49 is 1. Bring this 0 down here. And that gives us 7's into 10. 7 goes into 10 just once, doesn't it? So 1 times 7 is 7. Do the subtraction and we get 3. We are running out of space. Bring the next 0 down. And we get 30 there. And then 7's into 30 would go, I am running out of space. Got nowhere to write. So 7's into 30 goes 4 times. So 4 7's are 28. So if we had enough space, we'd write the 28 under the 30. And we would get 2, which would bring us right back to the beginning again, so that you could see that if we put the next 0 in here, I'll just do it, we don't really need to do it, so we put the next 0 there, we're just going to go around in a circle, really, well, not exactly a circle, maybe a spiral, doing the same thing over and over and over and over again. We're going to get 0.285714, 285714, and so on, forever. But luckily, mathematicians have got a way of showing this, and we just put dots on top of the number. So we don't actually need to write this bit down. All we do is put a dot on the first number that's repeating and a dot on the last one, and that means that all those digits are repeating. So that's looking at using long division to do this division. Let's do short division next, so I won't run out of space this time, hopefully. Okay, so that's the long division put away to one side, and I've shrunk it down so that I could write down the next steps there. So you can see that the calculation 20 minus 14 is appearing again. Of course, all the other calculations would turn out to be the same. So we know that the answer of 2 divided by 7, or 2/7, is 0.285714 recurring. So let's just show how we can do this division by using short division instead. So we will start off in exactly the same kind of way. So we're going to be dividing 7 into 2 point, and then loads of zeros in there. How many zeros did we need before? 1, 2, 3, 4, 5, 6. Okay, let's put them all in to start with. Might make life a bit easier. So hopefully that's enough space. They're getting bigger, aren't they? Anyway, never mind. So we're doing 7s into 2, doesn't go, so that's 0 point. And then I can bring that little 2 up here. So I'm dividing 7s into 20, goes, well, 7 goes into 14 twice. And 14 away from 20 is 6. So 7's into 60 goes 8 times. 8 times 7 is 56. So 60 away from, no, 56 being taken away from 60 leaves the remainder of 4. So that goes there. So 7's into 40, well, that goes into 35 5 times. Remainder of 5, because 40 minus 35 is 5. 7 into 50 goes in 7 times with a remainder of 1, because 50 minus 49 is 1. 7's into 10 goes once, because 1 times 7 is 7. The remainder is 3, because 10 minus 7 is 3. And 7's into 30, well, it goes into 28 4 times with a remainder of 2. So now I'm back to the beginning. I can see that I would get the same numbers cropping up again and again and again. So that is my answer, taking up a lot less space. But if you prefer to write it down the other way, that's all fine. You can see the same numbers are occurring over and over again. The little remainders, 2, 6, 4, 5, 1, 3, are the numbers that we had in our long division, and we wrote the 0 down next to them, whereas here we're writing that number next to the 0 that's already there. So we can write down that 2/7 is 0.285714 recurring. And you might like to check whether or not this is a sensible answer. I suppose one way would be to think, what would 1/7 be? And then just double it. I suppose you could think, how many times does 7 go into 100? What would that be? We know 7 7s are 49, so 7 times 14 will be 98. So yeah, 7 into 100 is about 14, just over 14. So it would mean that you'd get 0.14 for 1/7, well, not 0.14 exactly, but roughly just over that. So when we double that, we get 10.28 something or other. So yeah, that looks fine, doesn't it? Of course, if you were going to round this number to a certain number of decimal places, then you'd need to think carefully about that. So for example, if you wanted to give this number to 2 decimal places, the 5 after the 8 would round the 8 up to a 9, so it would be 0.29. Okay.